All right, well, I just recorded this video, all 16 minutes of it, and then realized that my microphone was off. So I'm going to do it again. And I really hope that someone watches it and it's helpful. So here we go. Simplifying complex numbers. Okay, if we have 2 plus 6i and a 4 minus I, and there is an addition or a subtraction between the two, make sure that you are subtracting. So a lot of times we're always multiplying, so be careful. This means that you're subtracting. With subtraction, you do have to distribute the subtraction to both. So minus 4 and then minus a negative 7i will be plus 7i. From here, we can combine like terms. 2 minus 4 would be negative 2. We want the real part to come first. And then 6 plus 7, 6i plus 7i would be 13i. Now, if we don't have any addition or subtraction between either a group of two parentheses or you have one term in front of a parenthesis like that, then that does imply multiplication. So if you have a monomial term times this, you need to just distribute that. So 3i times negative 4 will be negative 12i. And then 3i times 5i will be 15i squared. Then remember, anytime you get an I squared, you need to replace that with negative 1. So I'm going to rewrite this as 15 times negative 1, and that's going to give me negative 15. I want the real number first, so negative 15 and then minus the 12i. And that's our answer, simplified. All right, I decided this, so I do a couple, that I'm going to leave some for you to do. Sorry, it's 10 o'clock, I'm tired now. And then I will finish these up and post the answer key for this as well. Okay, to divide complex numbers, you have to multiply both the top and bottom by the conjugate of the denominator. So the denominator here is negative 2 plus I, so the conjugate would be negative 2 minus I. And then you would do negative 2 minus I on top as well. So then multiplying out the top, you get 3 plus I times negative 2 minus I. You'd get 3 times negative 2 is negative 6. Negative 2 times I would be negative 2i. 3 times negative I would be negative 3i. Negative I squared. And then remember, I squared equals negative 1. So you have negative, negative 1. Essentially, this is going to be a positive 1 here. Then combine like terms, real parts first. So negative 6 plus 1 would be negative 5 on top. And then you have the imaginary parts, add those together. Negative 2i plus negative 3i would be negative 5i. And then multiply out the bottom. So we have a negative 2i and a negative 2 minus I. Negative 2 times negative 2 is positive 4. Negative 2 times I is negative 2i. Negative 2 times negative I would be positive 2i. Negative I times I would be negative I squared. Negative I squared is going to equal positive 1 again. The middle, negative 2i plus positive 2i equals 0, which is what we want to happen because they're conjugates. So 4 plus 1 gives me 5. Now this simplifies because they're all divisible by 5. So you can actually factor out of 5 from the top and get negative 1 minus I. Factor out of 5 from the bottom because 5 is 5 times 1. So take out that 5 and you're left with negative 1 minus I over 1. So this simplifies to just negative 1 minus I. I kind of ran out of room there, but that would be my answer. Okay, 2 over 3 minus I. Oh, excuse me. So the conjugate of the bottom would be 3 plus I. And then 3 plus I. Okay, multiply out the top. I actually don't need a box for this one because I have a monomial term times a binomial, so I can just apply the distributive property here. 2 times 3 would be 6. 2 times I would be 2i. You do need to multiply out the bottom. However, if you remember, conjugates do multiply. specifically where the middles cancel, so you could just do the outsides. 3 times 3 is 9. I times negative I is negative I squared, and that's going to equal positive 1. Because in the middle, you're going to get negative 3i and then positive 3i, which equals 0. So you can ignore that essentially. So 9 plus 1 is going to give me 10 on the bottom. Now these are all divisible by 2, so I can factor 2 out from the top, and then if I divide a 2 out, I'm going to be left with 3 plus I, dividing both terms in the top by 2. Factor out a 2 on the bottom, that's 2 times 5. So you're taking that 2 out, I'm left with 3 plus I over 5, which can be written like that. If I want it in standard form, a plus bi, then that's 3/5 plus, this is a 1i, 1/5 I. So the real part is the 3/5, and the imaginary part is 1/5 I. Okay, you go ahead and try a couple. Next, we solve by square roots. The goal when solving by square roots is to isolate the piece that is being squared. So we need to get this by itself. So first, I'm going to start by adding 8, just like I would with any other equation. If I had a minus 8 and I was solving it, that's where I would start. So 0 plus 8 is 8. And then you cannot distribute into a parenthesis that has an exponent. So I can't distribute into this parenthesis at all. So this times by 2 in front, I need to get rid of by dividing by 2. And I'm going to rewrite this up here. So I'm going to be left with x minus 3 squared, and then 8 divided by 2 is 4. Now that I have the x minus 3 squared by itself, I can take the square root of both sides, because a square root is the inverse of squaring something. So the square root will undo the square. So I'll just be left with x minus 3 on the left. Then the square root of 4 is both positive and negative 2. Last step would be to add 3 to both sides. Commonly, you'll see this written as 3 and then plus or minus whatever you had there. But in this case, it's 3 plus or minus 2. So I'd like you to add and subtract. 3 plus 2 would be 5, and 3 minus 2 would be 1. So you get 2 rational answers here. Okay. Again, we want to isolate this part that's being squared, so we have to get rid of this negative 1/2. It's negative 1/2 times this, so your thought is, I'm going to divide by a half. When we divide by a fraction, we're actually wanting to multiply it by its reciprocal. So that's the rule when dividing by fractions. You multiply by its reciprocal instead, because then you get negative 2 over negative 2, which is 1. So on the left, you get x plus 5 squared still. And 8 times negative 2 is negative 16. So now we have the quantity squared by itself, so we can take the square root. That will undo the square, and I'll be left with x plus 5. The square root of negative 16 is plus or minus 4i. We get the square root of 16 is 4, and the square root of negative 1 is the I. And so that's where the square root of negative 16 comes from, the plus or minus 4i. Then we subtract 5 from both sides, and we get x equals. We're going to write it as the real part first, and then plus or minus 4i. So these are two complex solutions. Really, it's negative 5 plus 4i, and then my second complex number is negative 5 minus 4i. So I have two complex solutions for this example. So you can try a few. Okay, find the number of solutions by using the discriminant and then solve using the quadratic formula. So first of all, the quadratic formula is x equals negative b plus or minus the square root b squared minus 4ac all over 2a. And then the discriminant is specifically is the b squared minus 4ac part, and that tells us how many solutions we're going to have. So if the discriminant, the b squared minus 4ac equals 0, then we have one rational root, one real answer. If the b squared minus 4ac is positive, so it's greater than 0, then we're going to get two rational roots, or two real solutions. If the b squared minus 4ac is less than 0, so negative, then we're going to get two complex solutions, or two complex roots, which means that they're going to be imaginary. So rational roots are real because rational numbers are part of the real number system, and complex numbers are imaginary. So two complex numbers. Okay, so I'm going to start. First, it has to be in the form ax squared plus bx plus c equals 0. So it has to be equal to 0, which it is. So you can identify your a is 2, your b is 1, and your c is 1. So finding the discriminant first, b squared minus 4ac will be 1 squared minus 4 times 2 times 1, which is 1 minus 8, which is negative 7. So that tells me that I'm going to have two complex roots as my answers, which means this parabola is going to open up because my a is positive, but it's never going to cross the x-axis because it has two complex roots. And rational roots are x-intercepts, where the solutions, like the y values, the x values that make the y 0. So where it crosses along this, where y is 0. So complex roots means no x-intercepts. So then I can finish solving this by plugging into the quadratic formula now. So x equals negative b would be negative 1 plus or minus the square root b squared minus 4ac all equaled negative 7 all over 2 times your a value, 2 times 2. So simplifying this, I would like to try to, factor tree the square root if necessary, but 7 is prime, so the only thing I can do is take out the square root of negative 1. So negative 1 plus or minus the square root of negative 1 is I, and then square roots of 7. So square root of negative 7 simplifies to I square roots of 7 all over 4. So I have two zeros here, negative 1 plus I square roots of 7 over 4, and negative 1 minus I square roots of 7 over 4. So two complex roots. Leaving it like this is fine too, but I just want to make sure you understand the two roots. Okay, you go ahead and try that one. All right, the last thing we did was completing the square. So to solve by completing the square, step 1, you had to make sure a was 1. So my a in the first one is negative 3. So to get it to equal 1, I need to divide everything by negative 3. And I need to do that to both sides. So we're going to get x squared and minus 2x minus 1 equals 0. The next step to completing the square is to move the c value to the right. So that's the negative 1, so adding 1. We get x squared minus 2x. Then I'm going to complete the square. So I always like to add my blanks, plus blank, and then 1 plus blank. In that blank, you take your b term, you divide it by 2, and you square it. So in this one, it would be negative 2 divided by 2 is negative 1 squared would be 1. Add that to both sides. Then factor this. It always factors to whatever you got when you divided b by 2. But it multiplies to 1, adds up to negative 2. It's going to be negative 1 and negative 1. So it's going to be x minus 1 squared. It should factor to this perfect square because you made a perfect square trinomial, hence the name completing the square. It's kind of the whole point of this method. 1 plus 1 is 2. Then solve by square roots. So square root, because that'll undo the square, and you're left with just x minus 1 equals plus or minus the square root of 2. Then add 1 to both sides, and you're going to get x equals 1. In this case, 1 plus or minus the square root of 2. I'm going to leave my answers like that. My two answers are 1 plus the square root of 2 and 1 minus the square root of 2. I want the exact answers, and 1 plus the square root of 2, I did that earlier here, is irrational. So that's why we leave it as a... leave it like this, 1 plus the square root of 2. But this means that this parabola that opens down has a x-intercept at 2.4. So it has two rational roots this time. So it has two x-intercepts. They're just not whole number x-intercepts. All right, I'll do it one more time. So divide by a. make sure a is 1. So in this case, 2. So x squared plus 4x plus 5 equals 0. Move c, so subtract 5 from both sides. X squared plus 4x plus blank equals negative 5 plus blank. Then take b, 4 divided by 2, 2 square it, you get 4 again. Add that to both sides. Rewrite the left as a perfect square. That'll be x plus 2 squared because multiplies to 4, adds up to 4, 2 and 2. Negative 5 plus 4 is negative 1. Then take the square root of both sides to undo the square, and you're going to end up with x plus 2 on the left. The square root of negative 1 is plus or minus I. So don't forget, you always get 2 answers there in that step, plus or minus. Then subtract 2. Get x equals. We're going to write this one as complex solution. So the real part comes first, then plus or minus the imaginary piece. So these have 2 complex roots, which means this parabola does not cross the x-axis. It's negative 2 plus I is one solution, and negative 2 minus I is your other complex solution. So 2 answers, which can be written like that. All right, hopefully this has some sound, or I'm not doing it again. I think it was 2 minutes shorter this time, though, so that's a plus.